Hello, video game nerds. It's another episode of our first project, Planetary Defense V2. And today we are talking about explosions, and that has to deal with animated sprites. So we'll be talking about that and how it impacts collisions. So let us start off by showing you the latest and greatest version of our Unity app. Okay, all right, here's the Unity app, and we have put in a little target here, and let's go ahead and shoot it. Oh, and there's the explosion, and it gives us another target right down here. Okay, oh, and a target over here. Let's shoot a couple bullets. You can see that the bullets can hit the flak and create another explosion. All right. Now, that was one part which we had to get done, was being able to blow up the target and make an explosion. The other part was to create an explosion on the planet and have it eat away part of the planet. We call it the eating alpha setting. So if I hit the planet, you can see that, oh, look at that. It took a chunk out of the alpha. It actually changed the texture. And now, right, the clipping has changed, so it changes the collision detection. Because now it can go, oh, look at that. Oh, look at that. It's pretty easy to blow a hole in your planet. And I can get it from the other side too. Look at that. Now I got a hole completely through the planet. Let's see. There we go. That planet was in the way, right? So, what did we have to do? Well, first we had to create an animated sprite for this explosion. And then we had to modify our collision detection for two things, for the animated sprite and also for this eating the alpha setting. Okay, so let's take a look. I think we'll go to the 3D overhead view, and we'll look at some of the things we had to do to create both of those effects. All right, to the 3D overhead view. And the first thing we're going to talk about is the animated sprites. So, a sprite is a picture that is stored in a texture, and it gets moved around. When the sprite moves, the texture moves along with it. So the sprite is keeping track of things in the 3D world, and the texture is a pixel, and so it's in the 2D world. And usually there's just one frame of it. A single frame, a single texture. When you do an animated sprite, you have one texture. This whole thing is a texture, and you divide it up into these cells for each frame of the sprite. And you can then animate between them, or you can stay on one, and then when it changes direction or position, you can switch to some of the others. There's lots of ways to do it. In my explosion, I just have it go through all the way to the end, and then the last frame is a blank. So that way it doesn't leave anything behind on the screen. So what happens is when we're doing our per pixel collision detection, we are taking, let's say we're taking the bullet, okay, and we're comparing it to the texture of the explosion. Right, this is a bullet, and this is the explosion. But what happens is when we compare the pixels, we're grabbing the texture. See, this is the texture for this one. We're grabbing the texture and we're checking the overlap rectangle and comparing the pixels to see if we match. The problem is this texture has all these other cells in it, but when we look for the texture, we're getting this whole thing. And this is the 0, 0, and this is the width and the height, or the top and the right. So we need to know what pixel or what sprite we're at, so then we can compare the right part of the texture to the other one. Okay? So in the sprite, it's keeping track of which cell number it is, but it actually isn't doing it by cell number. It has a texture rect. And so this texture rect says what part of the texture it's actually drawing out on the screen. So when we do this per pixel collision, we check this texture rect to see what the offset should be. This is 0, this is 80, this is 160, this is 240, this is 320, 400, etc., etc., etc. So we had to modify the per pixel collision to check for this texture rect to see if it's been offset in any way, and then use that to point to that part of the texture to do the comparison. All right. So that's sort of the hiccup that animated sprites do, but you can just code this in and it works with single and animated sprites with no problem. And so that's what we did. Now, the other part which we did is something that we call the eat alpha. This is something we did for the planet. The idea is when something hits the planet, we want it to take a chunk out, with the explosions. So we're already looking at the collision area based on our per pixel collision detection. Per pixel collision. So when we see that it's not blank, is also the same as not blank on the destination, right? This is the original. This is the destination. So we know that it collides. Now the other thing we can do is we can see if the eat alpha is true, then instead of getting the pixels, we can then say set pixel, and we can say what our current X and current Y is and set it to clear. And so as it's going through doing the hit check, it says, oh, if I'm supposed to eat the alpha, then let's just set this to clear. So that will automatically take a chunk out of the texture, which is what we want it to do. Again, we have to do the offsets to make sure it's working okay. Now, when you do a set pixel, it's updating the texture. We're not updating the collision mask. We're updating the actual texture, and so we do the set pixel, but nothing's going to show up until we do the call to texture apply. And that says, hey, all the texture changes I made, apply them to the screen, and apply them to the actual texture. Now, this texture apply command takes a lot of cycles to do. This set pixel doesn't take much at all. So we need to make sure that we do this texture apply just once at the end of the check. All right, and so that's how we made it eat the eat part of the planet, because the planet is the only thing that we set for eating the alpha, because that's the only thing that's going to be made smaller and smaller by hitting it. I wouldn't recommend hitting your planet. That's a quick way to end your game early. All right, So there we go. That's animated sprites, and that's eating the alpha with our per pixel collision. And that's another reason why we had to do the per pixel collision, to help, eat up the planet that you hit. All right. So this pretty much concludes what we set ourselves up to do last time. So let's take a look at our brainstorm. I've made it into a backlog, and we will go through and decide what's the next thing for us to work on. Okay, so I'm going to switch back over to the screen. All right. Okay. Let's talk about our to-do list. So this is a Planetary Defense V2. So this is what I did was I took the backlog, or not the backlog, I took the brainstorming session, the different bullet sections, and I put it into this backlog. And you can see I have better graphics here. I have waves. I've also sort of broken it down to what it takes to make the different waves. And if you see here, I have like different sizes here next to it. These are like t-shirt sizes, right? Small, medium, large, extra large. And so this is just me doing a quick estimate of how much effort it would take to do these particular steps. So for doing waves, we're gonna have enemy control. That means, controlling when the enemies come out, detecting the wave end, when either all the ammo's gone or all the enemy is gone. This is for the bonus round, right? Count up how much ammo is left. Count up how much planet is left. Detecting the end game. That's something we got to add when the core of the planet gets destroyed. And detecting it out of ammo. So that's part of this detect wave end. Limited ammo. So that's putting in the ammo count, counting it up, or counting it down when we fire our bullets. Doing multiple enemies. So here's the bullseye. We've done that. We got the small bomb, the regular bomb, the heavy bomb, smart bomb, rocket ship, saucer, asteroids. So those are all medium, but altogether it's an extra large project. Different bullet types. We have this is an extra large step, but we have all the different things inside of it: rockets, mines, homing rockets. The super laser, that's going to be a little large. And we have our plus ups. We have ammo crates, shield, patching the holes in the planet. So this is stuff that came out of the brainstorm, and it is in this list. So what we need to do is we need to decide what to work on next. Better graphics. Let's just wait till we get to the point where we're gonna refinish our graphics and touch them up. Doing the waves, I think we need to do before we do the multiple enemies. Usually that's going to be the whole control system would probably be easier to get started with just the one enemy. And detecting the wave end. I think the first thing we need to do is probably doing the limited ammo. All right. So we'll put this as in progress. We'll do the limited ammo. And we'll do this detect out of ammo. All right. Let's also do the bomb. I think we can knock that out pretty quick. Enemy control, not quite yet. Yeah, so we got to do enemy control before we can detect a wave end and the bonus. Okay, and we'll stick with just this one bullet type for now. Okay, so this is what we got for our next step, and the whole idea is we want to get the game as functional as possible. The whole idea is you want to. It's better to have a finished game than a functional game than a completely finished game. Especially when it gets end of crunch time, there's usually the artwork or some other touch-ups. It's better to have something that you can refine and touch up at the last minute than something is working or not working at the last minute, right? So make it work, and then as you have time, add in all the niceties. Okay? So next video will be about counting the ammo and detecting when we're out of ammo, and we'll add the bomb as one of the first enemies. I don't count the bullseye as an enemy because it just sort of sits there and says, shoot me. All right. So that's it. We'll see you next time.